Hi, in this video I'll solve different quadratic equations just by completing them to a square. Let's go. Well, in this case we have this equation. The first thing I'm looking at is the middle term because I extract this coefficient which is minus 2. In this case I divide it by 2 and square it because this algorithm will give me the secret ingredient in order to complete this to a square. You can check our previous videos. Let's go. The first two terms, x squared minus 2x. Now I add this 1 and I have my perfect square. Let's check it out. Square root of x squared is x and square root of 1 is 1. The sign here should be a minus sign because the middle term is negative. So actually this is x minus 1 squared. But I cannot just add 1 here in order not, I cannot change the equation. So I have to put a minus 1 here and there is this minus 3 coming from the original equation. So this turns into this equation. Okay, now from this point, I just solve the equation. Minus 4 goes to the other side as plus 4. And I take square root of both sides. But check out. Now, this is either minus or plus 2, right? Because both, when squared, both gives 4 to me. I mean, minus 2 squared is 4 and 2 squared is 4. So I can write both of them as this is a square. Okay. Now this minus 1 will go to the other side as a plus. Let's do that. Plus 1 minus or plus 2. Well, this gives us two roots, which is one of them in this case is 3 and one of them is minus 1. That's all. This is solving this equation by completing the square. Let's go to another one. I picked 3 examples because now I will show you an equation with irrational roots. Okay, which has roots with irrational parts. Okay, let's go. That's the equation that we are going to deal with. The middle term is minus 4x and its coefficient is minus 4. I divide it by 2 and square it. And I find my secret ingredient, right? So I add my secret ingredient in order to complete this to a perfect square. But if I add 4, I need to put minus 4 in order to make it 0, right? I cannot change the equation. And there is this minus plus 2 coming from here equals 0. Okay. Now, let's check out this one. Square root of x squared is x and square root of 4 is 2. And the middle term has to be a minus because this sign should be minus because the middle term is a minus, okay? X minus 2 squared. So this part makes minus 2 equals 0. Okay, let's go. Let's solve this equation. Minus 2 goes to the other side as plus 2. I take square root of both sides. So x minus 2 equals to plus or minus square root of 2. Okay, now we'll pass that minus 2 to the other side. Now this gives me 2 roots. Let's check them out. 2 plus square root of 2 and 2 minus square root of 2. That we can call x1 and that we can call x sub 2. Okay, one last example which will have complex root. Let's see that. X squared, well, that's not squared. X squared plus x plus 1 equals 0. Okay, now the coefficient of the middle term is hiding, right? It's actually 1. So I take it, divide it by 2 and square it. Here is my secret ingredient and I go on. Now I add it. I also need to subtract it. This is the pattern, and this plus 1 comes, equals 0. All right. Now let's see that part. Square root of x squared is x, and square root of 1 over 4 is 1/2. And the sign should be plus, right? Because the middle term is plus. So this is x plus 1/2 squared. Great. So what about this part? Well, let's do it too. I expand it with 4. So this is what I get. 3/4. Just like the others, I'm just solving the equation. Okay? X plus 1/2 squared equals minus 3 over 4. Now I take square root of both sides. Nothing is different, just sets of numbers. That's x plus 1/2 equals square root of minus 3 over 4 plus or minus. Seems complicated, but stay with me. Now this plus 1 over 2 goes to the other side as minus 1 over 2. And I have square root of minus, well, let's take this 4 out of the square root and let's write it as 2. So I can write it as minus 1 plus or minus. Now check this one. Square root of 3, I, as this I can denote this square root of minus 1 as I, okay, divided by 2, as they share the same denominator. You see, now x has 2 roots, but it has complex roots. Okay, what else can I do? Let's do one more with a coefficient different from 1 for x squared. Now I'll just throw random numbers here. Okay, let's say minus 5 and let's say 9. I don't know if anything easy happens with this one. Okay, so let's go. Equals 0, of course. In order to solve such equations, first of all, you have to get rid of the coefficient of x squared. How do I do this? By factoring 3 out, of course. You see, I divide the middle term by 3 now, just like I'll divide this one by 3. It will become 3 here and equals 0. You see, I factored out 3. Now I divide both parts by 3. This will keep being 0, as 0 divided by 3 is 0, and these cancel out each other. Now, just like the old times, you see that? Now, I will employ the exact algorithm. Nothing is different, just rational numbers, just a little bit messier calculating, but basically everything's the same. Let me show you. Now, the coefficient of the middle term is minus 5 over 3. I divide it by 2. I square it. There you go. Now you have your ingredient for completing this equation to a square. X squared minus 5x over 3. I add what I found. I also need to subtract it in order not to change the equation. Plus 3 equals 0. Now, this part is the perfect square part, which is x minus 5 over 6 squared. Okay, let's do this operation. Minus 25 over 36 plus. Well, this 3 has this hidden denominator, so I expand it by 36. Okay. I do the calculations, it's okay. Now, plus 83 over 36 equals 0. Okay, the number, I know the numbers are messy, but that's good because it shows you that you don't need to see good numbers in order to solve an equation. Okay, you can solve the equation with messy numbers, with complicated numbers, right? So, okay, x minus 5 over 6 squared equals minus 83 over 36. Well, that's the part where I get square roots of both sides. So it's x minus 5 over 6. Well, I don't need the parentheses, right? I got rid of them. X minus 5 over 6 equals, now the square root of this, but with plus and minus signs, of course. So now x equals, I move this 5 over 6 to the other side of the equation, plus or minus, so I have both roots, right? These are, these are going to be my roots. Okay, but we can write it in a prettier form, in a complex number form. How can I do this? Well, let's separate them. X sub 1 equals 5 over 6 minus, 83. You know what I do this minus? I put an I here, and 36 will get out as 6. Now I have the common denominator, so I can write it as this. Okay, it looks pretty complicated, and it's a complex number, but you get the idea. Okay, this one's going to be with plus. Let's do it with plus, and we're done. Irrational numbers, complex numbers, rational numbers, real numbers. Well, in the next video, I suppose it's time to prove the quadratic formula through completing the square. See you in the next video. Bye-bye.